Well, so far we've looked at correlation to talk about how strong the relationship is between two variables, and we talked about defining the linear regression equation. Well, the question is, do we know something's truly linear? And to find that, we're going to have to go through and find what we call a residual plot. Remember, our residuals we talked about the other day is your observed y value minus your expected y value. So what you expect to get for your response variable compared to what you actually do get. Also keep in mind that if you end up with positive residuals, just by looking simply at the formula, the observed is larger than expected. If you get a negative residual, the observed is smaller than expected. So what is a residual plot? Well, residual plot is just a scatter plot. But instead of graphing x versus y, you're going to graph x versus the residuals. By doing this, you're going to end up with values, because the residual can be positive and negative, that go up and below the horizontal axes. And that's okay. That's what we want. But now the question is, when we look at the residual plot, how do we determine if we actually have a linear relationship? Because if we don't, this whole linear regression idea makes absolutely no sense. Well, this may seem strange, but what we're looking for in this case is a random distribution. We do not want any pattern to show up. If you see a pattern, if you see the points show any which way where it might be in some kind of a line or some kind of a quadratic or a funnel shape, we do not want to see any of that, nor do we want to see any clusters. If we have those things, then we have to question whether we do truly have a linear relationship. The example we're going to look at, we're going to use the calculator, because doing this by hand would just take way too long. So what I want you to do is keep referring back to your steps, and we're going to go into the next slide and we're going to talk about how to make a residual plot and then what it actually means. Well, the example that you have in front of you, we talk about the number of absences a student has and their final grade for the course. What I went ahead and did is I used the formula. In this particular case, it's the expected grade is equal to 100.13 minus 3.47 times the number of absences. And I got this just by doing my linear regression steps. This is an unnecessary step, but I do want to show you this because this is how I find my residuals. Well, in this particular case, the student earned an 82. We predicted using the equation they were going to earn a 79.3. When I subtracted 2, that's where the residual of 2.7 came from, because the grade they earned was higher than what we would have expected. Well, now I'm going to go through all the steps. If you go into a calculator, you put your information into a spreadsheet, your absences and your final grade, you follow your linear regression steps, and then you want to go ahead and you want to make a scatter plot. And when you make your scatter plot, notice that your x-axis is your absences, which is also my x variable. But now instead of graphing it against y, we're going to graph it against the residuals. So what we notice here is we ask ourselves, does a pattern show up? If there's no pattern, if it's truly linear, then we're going to see very randomly distributed. Now there is a little bit of random distribution here, but I'm a little bit concerned because I do see a little bit of a shape. It looks like the students who fell in between 5 to, let's say, 9 absences scored higher than expected, where less than 5 and more than 11 seem like they scored lower. So right away I would question this and ask myself, is it actually a linear relationship? And we'll focus on more of these as we get into class.